Hello, I'm Mr. McBrien. This is SPH3U, Gravitational Potential Energy. So the Ontario curriculum specifies that students will explain the concept of gravitational potential energy, giving examples, solve problems involving the relationship between power, energy, and time, and conduct inquiries and solve problems involving the relationship between power and work. Today, we're going to spend a few minutes talking about the value of elevation, learning how to calculate gravitational potential energy, and then do an activity calculating the number of calories we burn in our power output. So, the value of elevation. Whenever we have objects with an opportunity to fall, we have energy. So, examples: skiers at the top of a hill, hydroelectric dams, roller coasters at the summit, bowling balls perched on top of shelves, anvils at the top of cliffs. When we want to talk about how much energy, we can talk about the work involved in getting that object up to this height above a given space. So the force that does the work has to be equal in magnitude, but opposite in direction to what? Well, the weight of the object. So if we want to move something up without accelerating it, we just have to have a force equal to the weight of the object. Now remember that work is equal to force applied across a distance. Well, we can substitute in for that force then with the mass times gravitational acceleration, or g. And instead of the delta d, we can put the height in. So once we've done this, we have a pretty nifty expression for gravitational potential energy, the work required to move something upward. So gravitational potential energy then, we can say it's the mass times g times the height. And we'll often just simplify this, and instead of saying change in height, we'll just say height. And this height then, it's important that we specify it according to some reference point. There's no particular spot on Earth that we're going to say is always our reference point. So we need to designate it, of course. So let's take an example. An object of mass 3 kilograms is lifted at constant velocity from a height of 1 meter to a height of 2.5 meters. Let's find the increase in gravitational potential energy of the object. So we're given 3 kilograms and a delta H of 1.5 meters, and our familiar 9.8 straight down, and we're asked to get our gravitational potential energy. So we can simply substitute into mgh and get 44 joules. Now that's all we're going to have time for today, because we're going to do the stairs inquiry. But please do work your way through the textbook questions, and we'll talk about those tomorrow. So today we talked about the value of height, calculating gravitational potential energy, and the work that's done in going up, whether that's calculated in calories or in Big Macs.